This time is the turn for physics class, and this time we're gonna talk about the intensity of sound waves. So far we have learned a lot about some concepts for waves. For example, we learned that mechanical waves need a medium to travel, and we also learned that sound waves are an example of mechanical waves who needs a medium to travel. Now this time we're going to use the intensity equation to calculate, of course, the intensity of a sound wave. Now let's take a look. This equation involves power that we learned it last year. Its powers are measured in watts, divided by 4 times pi, the radius, raised to the second power. Now let's do one example. It says, what is the intensity of a sound produced by a trumpet at a distance of 3.2 meters when the power output of the trumpet is 0.2 watts? Assume that the sound waves are spherical. As they're telling you that the sound waves are spherical, you can assume that it has a flat circular shape, okay, because a sphere is spherical. It's round, okay. Now we write the givens of this problem, and I have distance of 3.2 meters. That will be my radius, and the power output is gonna be, of course, my power, 0.2 watts. And I wonder what my intensity is. Intensity is unknown. So I apply the equation here. To calculate intensity, I need power, which is 0.2 watts, divided by 4 pi, which is a constant, and the radius, that is 3.2 meters to the second power. Let's do the math. This will be equal to 0.2 divided by 4 times, of course, by pi, times 3.2 to the second power. I have the intensity. I will write it in scientific notation. Let me Okay, I write it in scientific notation because the number was too small. So I got 1.55 times 10 to the negative third power. Now, how do we measure intensity? Let's take a look. Let's analyze the units that we have. We have watts in the top, and we have meters to the second power below. Now, let me tell you. The units for intensity are those two. Watt per meter square. So this is the intensity for this problem. And voila, that's it. Okay, let's do one more example of intensity of sound waves. Now, this time take a look. The intensity of sound from an explosion is 0.10 watts per meter square at a distance of 1 times 10 to the third power meters. Find the intensity of the sound at a distances of 5 times 10 to the 2 or to the second power meter and 1 times 10 to the second power meter, and 10 meters. So, basically, my givens are givens. I have the intensity to be 0.10 watt per meter square. And I know to have this density, I had a distance of 1 times 10 to the third power meters. Now, what do I need to calculate intensity? I need the intensity unknown, but I know that I have a distance 1 of 5 times 10 to the second power meter, a distance 2 of 1 times 10 to the second power meter, and a distance 3 equals 10 meters. To calculate intensity, I need power and I need distance. I don't have power, but we're talking about the same explosion, so that means that with the first givens, we're able to calculate the power of the explosion. So, how do we calculate the power? First of all, we're going to calculate the power in order to get the other intensities. So power, if I isolate for it, everything that is dividing goes to the other side to multiply. So power will be equal to intensity times 4 pi r to the second power. So I have my intensity of 0.10 watt over meter square that multiplies 4 pi and the radius that is 1 times 10 to the third power meter. I do the math and I have 1 exponential 3 times 4 times pi times 0.10. I have my power to be 1.26 times 10 to the third power. No. Forgot to raise to the second power, sorry. Okay, I did my correction and my power turns to be 1.26 rounded times 10 to the 6th power watt. Or you can just write W, it's the same. Now meters and meters square are going to be cancelled here. Now that you have your power, you're able to calculate the intensity 1, intensity 2, and the intensity 3. My intensity 1 is going to be power 1.26 times 10 to the 6th watt divided by 4 pi. What distance? The distance given, that is 5 times 10 to the second power meters to the square. My second intensity will be the same power, 1.26 times 10 to the 6th power watt, 4 pi, 1 times 10 to the second power meter to the second power, and the third intensity the same but using its distance, 1.26 times 10 to the 6th power watt, because we're talking about the same explosion, and we have 4 pi, the distance, that is just 10 meters. So this distance, as I'm closer to the explosion, I expect this intensity to be the largest. Now let's see. Do all the math, and let's see. 1.26 exponential 6 divided by 4 times pi times 5 exponential 2 raised to the second power. This intensity is 0.4 watt per meter square. This second intensity is 1.26 exponential 6 divided by 4 times pi times 1 exponential 2 raised to the second power. This intensity is 10.03 watt per meter square. And the third intensity, this is raised to the second power, sorry, is 1.26 exponential 6 divided by 4 times pi times 10 to the second power. I have this intensity to be 1002.68 watt per meter square. As we predicted, I am closer to the source. The source is the explosion itself, so the intensity turns to be the largest. And that's it, guys. Thank you for watching.